So this will be the final video about the lander program in dflat. I'm adding some machine code to make the gameplay a bit smoother, and to do that I'm using the inline assembler, which is going to erase, check the collision and replot all in machine code. It will minimize the flicker but not completely. This is still not a fully optimized game. But then I've also added some of the finishing game elements, for example scoring and levels. So let's look at the main parts of what is required to allow the assembler to be called. Firstly, I just want to show here what have I actually replaced. So these commented out sections in green are the dflat commands that were plotting the craft, then checking the collision, and then replotting the craft its new position. Now it's all replaced by this one call to something called plot chip. What this command does call is invokes the machine code at this address, which is held in the variable plot chip, and then I can pass in the A, X and Y registers if I wish. Here I'm not using it. Now how do I actually create a machine code routine? Well, down here I have added a routine called assemble. What this routine does is to allocate some space in an array called ASM code of 200 elements. Each element is an integer, so it's 2 bytes, so that's 400 bytes of machine code that I could put into there up to. And then I'm calling this routine called do ASM 3 times with parameter 0, 0 and 2, and I'll explain what that is in a second. The actual do ASM routine is here, and it takes this parameter and then uses that to set the option for the inline assembler, and the ASM routine has to be called 3 times. It's a 3-pass assembler because of reasons of forward references and then having to resolve long and short addresses. It needs 3 passes. 0 means to do a pass without actually writing any machine code, and 2 means to do a pass writing the actual code to memory. And there's a few other options which I won't go into. Now, to be able to call the drawing routines and other ROM routines, I need to know what the location of those routines are. So I've put them in variables, pix routine and hchar routine. I know these values because I've looked it up in the assembler linker file, and I know exactly what these routines are and what parameters I need to pass into them. But essentially this routine, pix routine, is just the routine to get the pixel value, which I use for collisions, and the hchar routine is a high resolution plot character routine where I can plot the spacecraft in whatever position I need. So I set the option opt-o, and then I set the origin of the machine code to ASM code, which is actually the array that I've got 200 elements allocated for. And then I've got a label here, plot chip. Now all of the inline assembler functions are invoked with a dot first. So .ldx is basically LDX, but it tells dflat to invoke the inline assembler. And I can actually mix and match variables from dflat and assembler. So here the function addr with a variable inside the brackets resolves the address of the variable. So what I'm actually doing here is that this translates into an absolute LDX. So I'm doing LDX and the absolute value of the variable OX, and that is known by dflat, so you'll resolve that during assemble time. And one of the reasons why that is the case is that in dflat all variables have their space allocated for them during the syntax processing, during the tokenizing. So here what I'm doing is this is essentially the routine which plots the spaceship in its old position to erase it, and that's what I'm doing here. Then I go on to the collision checking, and I have a number of pixel commands that I was using, and each of those is replaced by a couple of lines of assembler, several instructions actually. And of course assembler is a little bit more fiddly than doing things in dflat, but the payoff is that it's going to be much faster. So I check the collision and I save the collision value before I then replot the spaceship in its position by loading the x value and the y value and the character to plot. And there's two characters, so I need to plot twice essentially. And then the previously saved collision value, which is on the stack, I pull that off the stack, and then I put the value into X, make sure that the A register is 0 because I'm returning a 16-bit value, and the low byte is in X, so the high byte is in A, and then I'm doing an RTS. And at that point, when the RTS is done, it returns to dflat, the call routine finishes, and the X and the A pair are used to form the return value, which is what is then stored in P. So that is the assembler. So how does that look? Well, let's firstly make sure that I've got a text file converted to a tap file, and then if I go to the dflat, I will then be able to load the program. It's quite a bit longer now because I've added some other elements, as I've said, so I'll just press F6 to speed it up back to normal speed now, and then I will press start. I'll enter start. There's a bit of initializing to do because of the assembler routine that's being compiled, and now I've got a very simple start screen with a few instructions, and then I'll press any key to start. Now what you should be able to see here is that the lander is a lot smoother in its movement in terms of flickering. Is there still some flickering? There's no way to stop the flicker with the ROM routines that I've got, and that's for two reasons. One is the ROM routines are not really optimized for ultra speed. They're due to space, they have to be a bit more generic. I didn't land properly, but because they have to be generic routines, it means that they're a bit slower than you could otherwise make in terms of an optimized piece of assembler. And the other issue with flickering is that the ORIC doesn't have a vertical blank interrupt or a way of knowing when the vertical blank has been executed in software. And the way around it is that there is actually a synchronization signal which comes out of the ORIC's RGB port, and it can be fed in with a flywire back into the ORIC's bus. I'm not going to do that because it requires essentially a hardware mod. So this is more or less the best that I think we can do with dflat using the inline assembler to get, I think, what is quite a smooth game. So one more go. Well, I'm not very good at that, but I hope you enjoyed the video and it inspires you to have a deeper look at dflat. Thank you very much.